Today you're going to be using microscopes to view living things in their cells. Although it may seem as though we've known about cells for a really long time, we weren't able to properly understand cells until we had the proper equipment invented. So let's talk about the road to discovering cells.
Antoine van Leeuwenhoek was a Dutch businessman and scientist. In his life, he made various lenses that he put into very small microscopes. Those microscopes used the light from the sun or sometimes candles to help illuminate the specimen. In the 1670s, he discovered the microscopic world by viewing water underneath the lens of one of his microscopes. In that water, he noticed things moving around and called them animalcules. Most of what he saw is what we now refer to as unicellular organisms, meaning organisms that are made up of only one cell. In 1665, English physicist Robert Hooke was viewing very thin slices of cork under one of the first light microscopes. He did many detailed drawings of the cork and noticed that they resembled the cells of a honeycomb. He then decided to use the term cell to describe all biological organisms, therefore giving cells their name. As microscopes continued to be made better and better, allowing you to see more and more detail, a German botanist named Matthias Schleiden continued looking at plants under the microscope, and in 1838, after looking at many plants, made the statement that all plants are made up of cells. The following year, German scientist Theodor Schwann, after looking at many animal tissues under the microscope, makes the statement that all animals are made up of cells. To put everything together, a German physician, Rudolf Virchow, created the cell theory in 1855. The cell theory is comprised of three parts. 1, that all living things are made up of cells. 2, that cells are the basic units of life. And 3, that new cells must be produced from existing cells.
Dissecting microscopes allow you to see details in living things, for example, scales in a butterfly's wings, but not actually their cells. So if we take a look at our dissecting microscope, all of our dissecting microscopes have a main power. Please make sure that that's on. Once that main power is on, if you look on the opposite side, you have your illumination. So you can have just the light coming down, or you can have your stage lit up, whatever works better for you. So once you've decided what you want to look at, I have a feather. You can put that on the stage using the stage clips to help you keep it in place. I have chosen to have my stage illuminated, and then you have your eyepieces. You have 2 eyepieces on a dissecting microscope with a magnification of 10 times. So when you combine that with the magnification from the nose piece, you either have a 2 times magnification or a 4 times magnification, which you can just rotate that nose piece to see either the 4 or the 2. I always start with the lowest power possible, so I'm going to switch that back into the 2 times magnification. Your total magnification would then be your 2 times your 10, so I'll be viewing this feather 20 times bigger than it actually is. When you prepare to look at your specimen, you're going to look through the eyepieces. If you happen to see your eyelashes, pull a little bit further away from the eyepieces. I like to close one eye, and as I'm looking through there, I can use my larger knob, which is your coarse adjustment knob, to move up and down until I see that picture as clear as it possibly can. Once you see that picture as clear as you possibly can, you can move up a power. So I'm going to rotate it now to the 4 times magnification for a total of 40, because of 4 times the 10. You should be pretty close to being perfectly clear, but you may need to adjust just a little bit to get your best picture. Our compound microscopes are going to be able to show us the microscopic details inside of our cells. Some may look a little bit different. You may have 2 eyepieces versus 1. You'll just use whichever one is most comfortable to you. Some microscopes are going to have the stage clips like you saw with your dissecting microscopes, but some have a mechanical stage. That's going to allow you to scan through your slide to see the best details possible. Your objective lenses are located on the nose piece, just like on your dissecting microscope, and you should be able to look at each objective lens for their magnification. So some of them may be 4, 10, and 40, other ones may be 4, 10, and 43. You'll just need to look on your actual objective lens for how much it can magnify. When you're ready to begin using your compound microscope, if you have a mechanical stage, you just slip your slide right in there. There's a little lever that will open up to allow you to even it up right in there. You then have 2 knobs that allow you to move the stage back and forth and left and right. You'll want to make sure that your specimen is right in the middle. So once again, you need to turn on your microscope. It will illuminate from the bottom this time, and we're always going to start with the smallest objective lens, which in our case is going to be 4. We magnify that by the 10 of the eyepiece, so we'll be magnifying 40 times. You're going to look through your eyepiece, and using your larger knob, which is your coarse objective, you're going to bring that up until you get it almost perfect in terms of your details. Once you have that all set, you can decide to move higher up in your magnification. So I've moved to the 10. You should be pretty close to being perfectly focused, but you may need to do a little bit of an adjustment with your coarse adjustment knob, or you can use the smaller one, which is called your fine focus. What that's going to allow you to do is really clean up and crisp up those details. Once you have your 10 magnified, you can go all the way up to your higher power, which is 40. So now I'm magnifying it 400 times. And at this point, you will only want to use your fine focus to get those details just as crisp and clear as you can. If we use our coarse adjustment knob, we risk bringing the stage up too high and actually smashing the slide on the objective lens, damaging both. So we don't ever want to use our larger coarse objective or coarse adjustment knob using your 40. We hope you have fun discovering the microscopic world today.